Dear student, in previous session I was explaining regarding the how to convert the given block diagram to signal flow graph and find the transfer function using Mason's gain formula. In this session also, I'm going to explain you how to convert the block diagram to signal flow graph and find the transfer function using Mason's gain formula by considering another examples, by considering the another examination. This is asked in the examination also, asked in the previous question paper. I've taken this as an example for converting block diagram to signal flow graph and then now to apply the Mason's gain formula. Here we know that the procedure, and clearly I was explained. I have explained in previous session. To go through the previous session for understanding the conversion process, converting the block diagram to signal flow graph. But anyhow, I'm going to explain briefly once again. Here, by converting, now what is the procedure? First step is to assume the nodes at input. Assume the nodes at input, at output, CFS point, at every summing point, at every take-up point, and in between the cascaded branch, and name these nodes. Here there is input nodes at this coming points and output point and cascaded branches. And I want to name these nodes as E1, this is E2, and this is E3, this is E4, E4, this is E5, this is E6. These are the nodes. We need to assume the nodes at every input point, output point, at every summing point. At every summing point, we need to assume. Here there is another. This is actually E4. Here there is a take-up point. This is E5, and this is E6. This is E7. This is E7. And then they, after assuming the nodes, need to name those nodes are E1, E2, E3, etc. Now, after naming, we should draw these nodes separately as small circle, and once again naming the same node, same name, R node, and this is E1 node. Go for rating separately, small circle. Next step is to identify the main forward path from the signal flow graph, from the block diagram. Now this is the main forward path. Starts from R node, E1, E2, it will go to E3, E4, E5, E6. It is the main forward path. From the main forward path, from the block diagram, identify the main forward path and gain between the nodes and mark here by joining the line. By joining the line or branch, by use it to connect the, after connecting these nodes by branches, we need to mention the gain. What is the gain between R and E1 is? This is 1. And gain between E1 and E2 is also, here there is a 1. Here the E2 to E3, E2 to E3, this is the E2 to E3 is G1. And here E3, from E3 to E4 is 1 again. Here in between E3 and E4, there is a gain 1. Similarly, E4 to E5 is again, there is a gain G2. And also from E5 to E5 to E5 to E6 is G3. Then E6 to and E6 to E7 is 1. And also from E7 to this node is 1. This is the way of constructing the main forward path of the signal flow graph. Next step is to, from the block diagram, identify the feed forward path between the various nodes. Identify the next step for feed forward path. Identification of the feed forward. Next step identification of the feed forward path. Now, what are the feed forward path? Feed forward path andre input side in the output side feed forward path. Those are called as from input side to the signal goes from input side to output side. That is feed forward path. So a signal coming from output side to input side. Those are called as a feedback signal. So here, now which is the feed forward path? Identify the feed forward between the various nodes. Here there is E4 node and E6 node. There is a E4 node and E6 node. E6 node. There is a feed forward path. Identify the feed forward path and connect or between this node and here and mention the gain of the feed forward path along with the sign. The gain is C4. The sign here, the sign usually actually plus. This is plus. Therefore, plus sign is plus. Mention the and then from the block diagram, identify the feed forward path between the various nodes. Mention the gain along with the sign. This is the second step. And next step we go for identify the feedback path from the block diagram and connect the node between the feedback path between the nodes and mention the gain along with the sign. Here now what is the feedback path? Here there is a 3 feedback paths. There is a from here to here there is a 1 feedback path. From here to here there is another feedback path. From here to here is another feedback. There are 3 feedback paths. From the block diagram, identify the feedback paths, and then join between the various nodes and mark the gain along with the sign. Now, what is the feedback path between E2 and E5? E2 and E5 means E2 and E5. This is the E2 and E5. There is a feedback path. This is the feedback path. Mention the gains. This is gain. This H1 along with the sign. The sign is I'm going to attach. Similarly, the H2 is a feedback path between E3 and E7 and mention the gain H2 along with the sign is negative. Therefore, here I should write negative. This is H2. Similarly, another feedback path here, there is a E7 and E1. Here there is a E1 and E7. Mention the gain. Here there is no gain. Then we should mention the 1. Gain will andre 1 agbeku. Therefore, along with this sign is with this sign we need to. If it is plus, here plus. If it is minus, here the sign is very important. So mark the feedback path along with the signs between the various nodes in the signal flow graph. This is the way of constructing the signal flow graph from the given block diagram. This is the way we are converting. Then by using Mason's gain formula, we can easily find out the overall gain or transfer function of the system. In the next step, I'm going to explain you how to calculate the gain, overall gain of the signal flow graph by using Mason's gain formula. In this particular step, we go for writing the overall gain. We go for writing Mason's gain. Overall gain can be calculated by using Mason's gain formula. Overall gain of the system represented by signal flow graph can be calculated by Mason's gain formula. In the we go for writing the Mason's gain formula. The Mason's gain formula states that the overall gain or transfer function is given by T of S is equal to C of S divided by R of S 1 by delta summation of K Pk into delta K. In this particular signal flow, there are only two forward paths. Therefore, K is equal to is called as a number of forward path. K is equal to 2. Therefore, no delta K Pk into delta K 1 by delta P1 into delta 1. Now K is equal to 2. Therefore, K is from 1 and 2. Therefore, Pk is P1 when K is equal to 1 P1 delta 1 when K is equal to 2 K2 P2 into K2. And then after expanding, in the next step, we need to calculate P1, delta P2, delta 1, delta 2, delta value. The next step in order to calculate P1 and P2 is nothing but the forward path gains. There are two forward paths. The corresponding forward path gains. First forward path gain is called as P1. Second forward path gain is called as a P2. In the next step, we go for calculating the gains of the forward path, gains of the forward. In second step, we go for calculating the forward path gains. The second step of calculating the overall gain of the system represented in the form of signal flow graph by using Mason's gain formula is first step is to write the formula. Second step is to calculate the forward path gains. Therefore, in the second step, identify the number of forward path. The number of there are two forward path. There are two forward path. Let P1 and P2 be the P1 and P2 be the gains of the forward path 1 and 2 respectively. Therefore, the gain of the forward path 1, the gain of the forward path 1 is equal to what is the 1? What is the is equal to the forward path starts from R0, first forward path, go to the E1, E2, E3, E4, E5, it will go to the E6. This is the main forward path. The gain is nothing but that is the go for writing. Start from R1, E1, E2, E3, E4, E5, E6, E7, and see this is the path of the second forward path, first forward path. Therefore, we need to multiply the gain. In order to calculate the gain, we need to multiply the branches gains or transmittance. Both transmittance and gain is same. We need to the forward path gain is the product of the branch transmittance of this particular path. Therefore, we need to multiply 1 into G1 into this again 1, G2, G3, again 1 and 1. Therefore, the gain of the forward path first is denoted as P1 and G1, G2, G3 is the gain of the first forward path. Similarly, we need to write down we needed to identify the second forward path and calculate the gain of the second forward path. We need to calculate gain of the second forward path. Forward path gain of, there are two forward paths. First forward path gain I have calculated. Gain of the second forward path is denoted as P2. Now, what is gain? What is the gain of the forward path second? Is now identify the second path. Start from R0, it will goes to the R node, E1 node, and then E2 node, and E3 node, and E4 node. And after E4 node, it via the G4, it will go to the E6 node, and then E7 node, C node. This is the way of. This is the way of. Therefore, here this is the path of SP2 is equal to, we need to multiply 1 into 1 into G1 is 1 into G1 into 1 into G1 into 1 into G4 again into 1 into 1. Therefore, G1 into P2 value is G1 into G4. The gain of the second forward path is G1 and G4. Gain of the second forward path after identification of the forward path. So we need to multiply the branch transmittance that gives the gain of the particular forward path. That particular forward path. The forward path andre starts from the input node, ends at the output node without crossing any node more than one. That is the definition. Second forward path starts from input node, ends at the without crossing any node more than once. Now these are not a forward path because arrow direction opposite ಇದೆ. If any other than this, you have to identify and then have to go for the next step. Otherwise, if you miss one forward path, then it will value of the delta is also wrong, and the further steps values will be going to automatically becomes wrong. That is what identification of the forward path is also very important. So once we identify, calculate the forward path. In the next step, go for calculating. The next step is to calculate the loop gains, individual loop gains. In step 3, we go for calculating the individual loop gains. Individual loop gains from the signal flow graph. Identify the loops. How many loops are present? There are 5 loops here. There are 5 loops. The first loop is the gain of the 5 loops be the P11, P22, P33, P44, and P44. These are the loop gains. So therefore, here the loop 1 starts from E2 node, E3 node, to go for E4 node, E5 node, and then via the minus H1 arrives at the same node. This is the loop 1 node. Similarly, this is the loop 2. Now this is the outer loop, is the L3. The other two loops are starts from the, this is the another loop, starts from this E3 node, go to the E4 node via the G4 and E6, then E6, this is E7, this is E7, via this is minus H2. This is loop 4, and similarly another loop is here. Start from the starts from E1 node, go to the E2 node, this is E3 node, E4 node, but similarly via the G4 come to the E6 node and go to the E7 node, and this is the path of the loop 5. This is the first loop, second loop, third loop, fourth one, and fifth one. These are the loops because the loop means starting. The loop means is a closed path. Is a loop is a closed path, starting and ending at the same node. Here, starting at node is ending at the same. Go to the E3, E4, E6 comes to the same node. This also same node. Similarly, here also E3 starts from E3, go to the E4 via the G4, comes to the E6. Here transmit is 1. Here also works. And minus H2. We need to write down now. Now, what is the gain of the loop 1 is denoted by P11. Then what is the P11 value? Is the gain of the loop 1. Therefore, G1 into this transmittance is 1 and this is the G2 and minus H1 is the gain of the loop 1. Similarly, gain of the loop 2, the gain of the loop 2, the gain of the loop 2 is indicated by P2. Gain of the loop 2 is indicated by P2. The P2 is equal to, what is the gain of the loop 2 is equal to product of the branch transmittance of the loop 2. Now this is the loop 2. This is the path of the loop 2. We need to multiply 1 into G2 into G2 into G3 into 1 into minus H2. Now this is the G2 minus G2, G3, H2 is the gain of the loop P22. Similarly, you should write the path also. Starts from, if you want, write the path also. Here, loop starts from E3, goes to the E4 node, E5 node, then E6 node, and E7 node, via the minus H2, come to the same E3 node. Now this is the path of the second loop. Similarly, the gain of the, we need to calculate the gain of the loop. We need to calculate the gain of the which loop? The gain of the next loop. We need to calculate the gains of the this particular loop, outer loop. We need to calculate a P3 loop. That is P33. This is indicated by P33. Therefore, what is the path of the gain loop is, which is the path? The path is starts from E1 node only, go to the E2 node, E3 node, and then E4 node, E5 node, E4, E5, E6, E7, E5, E6, E7, via the minus 1 comes to the same node. Now this is the path. Therefore, we need to multiply 1 into this G1 into again 1 into G2 into G3 into G3 into again 1. This is 1 into again that's minus 1. Now what is the value of P33? Is equal to G1 minus G1 because here there is a minus 1. Therefore, minus G1, G2, G3 is the loop 3 gain. Is the gain of the G1, G2, G3 is the minus is the gain of the loop 3. Similarly, we need to calculate the loop 4. What is the gain of the loop 4? Is denoted by P4, 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 4. Therefore, we need to calculate the gain of the loop 4. We need to calculate gain of the loop 4 along with the path. The P4, 4. What we need to calculate, consider this particular loop, find the gain. The gain means branch transmittance. Gain of the loop means is a product of the branch transmittance of the loop. Therefore, this loop starts from E3 node, go to the E4 node, Via the G4 comes to the E6, E7 comes to the same node. Now this is equal to P44. Branch transmittance is 1 into, now this is the fourth, 1 into G4. This branch transmittance is G4 into this 1 into minus H2. Therefore, minus G4 into H2 is the gain of the loop 4. Similarly, we need to calculate the gain of the loop 5. The gain of the loop 5, can be denoted by P55, and we need to here the gain of the loop 5 is P55. Therefore, this is equal to here this 1 into G1 this is 1. Therefore, G4 this is 1 minus 1. Now this is equal to branches product of the branch transmittance. So therefore here G1 is 1 into G1 into 1 into G1 into again 1 into G4 into 1 into minus 1 is the gain of the this is the 1 into G1 G4 minus. Now this is the gain of the loop 4. P44 is 1 into G4 into 1 into minus H2. I have written instead of minus H2 minus 1. That is wrong. This is the P4 value. So consider this value. Now similarly, because this is the loop. Last loop is this is the minus 1. Now this is the gains. Therefore, P55 is nothing but the gain of the loop 5 minus G1, G4 is the value. Therefore, this is the way of calculating the individual loop gains. In the next step, we go for calculating. In the next step, after calculating individual forward path gain calculation is over, individual loop gains over, we need to calculate the gains product of the non-touching loops. We need to identify the non-touching loop combinations and find the non-touch gains product of the non-touch gains product of the non-touching loops in step 4. In step 4, we go for calculating gains product of the two non-touching loops. But after observing the graph, after observing in the signal flow graph, all the loops L1, 2, L2, L3, L4, L5, all the loops having the common nodes. If the loops does not have this, the loops are said to be non-touching. That does not contain that does not have the common nodes, because here all the loops are touching to each other. Therefore, there is no combinations of non-touching loops. Therefore, there is no combinations of non-touching loops. Therefore, the gain product of non-touching loops are 0. Gain product of the non-touching loop is 0. In the next step, step 5, we go for calculating the delta value, determinant of the graph. In this particular step, we go for calculating step 4, determinant of the graph. The determinant of the graph is denoted by delta. The determinant of the graph is denoted by delta. Now, what is the formula for calculating delta? It's equal to sum of individual loop gains plus sum of gains product of all possible combinations of two non-touching loops, again minus sum of gain possible combinations of all three non-touching loops. Here what is the sum of gain individual loop gains? I have calculated what to sum P11 plus P22 plus P33 plus P4 plus P55. These are the individual loop gains, we have calculated these values, substitute this here in this particular formula. The sum of gains product of all possible combinations of the two non-touching loops is 0, because there is no combinations of two non-touching loops. So that term is equal to 0. In the next step, we go for calculating the delta k. The delta k means here k is equal to 2. It may be delta 1 and delta 2. Therefore, we need to calculate the values of delta 1 and delta 2 in next step. In step 5, we go for calculating delta k. We go for calculating the delta k. Here k is equal to is the number of forward paths. Therefore, since number of forward paths are 2, k is taken from 1 or 2. When k is equal to 1, delta 1. The delta 1 can be calculated similar way of calculating the delta. The same formula of calculating the delta k can be calculated by using the same formula of delta. What is delta? 1 minus sum of individual loop gains plus sum of gains product of the two non-touching loops plus again minus sum of gains product of all possible combinations of the three non-touching loops. This is the standard formula. Therefore, here delta 1 with respect to forward path 1. Here, if we consider the forward path 1, then all part of all branches of the graph which is stretching to the first forward path. Therefore, if I considering the any part other than the not touching to the first forward path, here for that particular graph, we should apply the delta. But here, if I go for applying the formula, delta is equal to 1 minus individual loop gains. 1 minus individual loop gains is 0, plus that product is also 0. Sum of gain product is also 0. Therefore, this is 1. So, since there is no part of the graph not touching to the first forward path and also second forward path. If I consider the second forward path also, all the parts of the graph is not touching to the second forward path also. Therefore, delta 2 is equal to delta n. Same formula of calculating delta part of the graph which is not touching to the second forward path. Since here also there is no part of the graph not touching to the second forward path, therefore delta is equal to delta is equal to 1 minus sum of individual loop is 0, product is also 0. Therefore, delta 1 value is equal to delta 2 value is also delta 2 is equal to 1. In the next step, we go for calculating overall gain of the system by using the Mason's gain formula. That is, I have written in the step 1. Step 1, yeah, you have to substitute this value, delta 1 value, forward path case, then we will get the overall gain of the system. In step 5 or step 6, go for calculating the overall gain or transfer function of this particular system, CFS divided by RFS. This formula I have written in step 1 itself. Therefore, substitute the values of P1 or delta 1, P2, delta 2, we have calculated delta value also. Now, what is P1 value? Is the G1, G2, G3 into 1. 1 is the delta 1 value, G1 into G4 into delta 2 value is 1. And this is the delta value. This is the delta value. Now, this is the overall gain of the system. Overall gain of the system are represented in the form of signal flow graph by using Mason's gain formula. In the next session, I'm going to discuss if the electrical network is given, then how to convert the electrical network into the signal flow graph and find the overall gain of the system by using Mason's gain formula. Thank you for listening.